And this is part C for the video. So if you haven't watched part A or part B, go back and do that. Skip through the videos. Please watch them, smartly. We created this shape. I added some color to it. I want to make sure that that's visible. We have our perpendicular bisector creator, or the other one. But this time we're going to actually answer the questions that are there. And so we're talking in part A, what do you notice about line segment BC and line segment HJ? So H is this top point right here, and HJ. And really about the only thing that I notice is that they are diagonals. BC and HJ are diagonals. Because of the way we use perpendicular bisectors, that's another criteria that they have. They are diagonals that are perpendicular. Okay. We also notice, I hope that you notice that they're not congruent. They're not the same length. But because BC is bisected in the middle, HJ is not bisecting, or is not bisected itself. The top line segment is a different line length than the bottom line segment, AJ. So only BC is bisected. So for that reason, only BC is bisected. We have perpendicular. We have only one of the line segments. This diameter right here is bisected, making AB, AC. That's it. They're not congruent. Now, using that information, it's also important then to go into the actual picture of the triangle. Determine the lengths of each side of the quadrilateral. So I'm going to measure BH, and let's use inches, all right? Just to make sure that I show that as a skill. So with the compass, with the straight edge measuring tool of the compass, we're going to put 0 on B. So you got to make sure you line it up right here, 0. And then out here on the edge, it even looks like it's marking, let's see here, so 1 inch, right? Let's see if we can kind of zoom in on this. Goodbye, face. Yeah. Okay, so we have 1 inch, and then it's actually going over a 1/16, 2/16. I'm going to say this is about 1 inch, and 2/16, that makes 1/8 inches. Let's go over here to this one. Same thing, measure HC. So if I did it right, 1 inch, fudge it a little bit, 2/16. 1 and 2/16 is 1 and 1/8. Let's go down here. So continuing to measure, I'm going to kind of flip the ruler around. Sorry if this flips the numbers around on you. 0 has to go on the point, and then quarter, half, 3/4, 1 full inch, 1/4, 5/16, 6/16, 6/16 makes 3/8. And then down here, CJ. So putting the 0 on C, go a quarter, go a half, go another quarter. That's a full inch. Go a quarter, 6/16 as well. You can even count them, right? So 1, 2, 3, 4, 5, 6/16, which reduces down to 3/8, 1 inch and 3/8, right? Let's bring it back out to full picture here. Analyze the lengths of each triangle. Well, we did. We found out that actually BH is congruent to CH, and CJ is congruent to JB. The other reason why we would know that is because this triangle, ABH, is the same as this triangle, ACH. Those two triangles are the same by SAS, side, angle, side. So therefore, their opposite sides are also equal. And then the last part, the bottom triangle, so that means that the two lines are the same size. And then down here, triangle AJB and triangle AJC, those are the same triangle, also because of side, angle, side. So the opposite sides that were not in the side, angle, side description, the rest, are also congruent by C, P, C, T, C. We say that after we say the triangles are congruent. Now, determine the measure of each interior angle of the quadrilateral. This is going to, again, take us some measuring. So here we go. I'm going to extend the line and extend this line. That way my protractor can actually measure it. I'm going to guess that's a 90-degree angle. I think it's a 90-degree angle because this line right here, this chord that goes right through the middle of the outer circle, creates a half circle. And so if you take a half circle, which is 180 degrees, and you create an inscribed angle on this chord, this is going to be 90. But let me confirm it. I mean, other than the fact that I'm human and I made a small little like adjustment, like that looks like an 89, it's actually a 90-degree angle if I'm perfect. So angle J, the measure of angle J, so that's B, let's go CJB, is 90 degrees. Again, pay attention to the middle letter. That's angle J. I have to continue on with extending the lines because the protractor is so much bigger than the circle. So here we go. I'm going to draw line CH longer. I'm going to draw line CJ longer. And then I'm going to measure it. It looks like it's an angle that's less than 90 degrees, like smaller in span than a piece of paper. So let's just get a measurement here and line it up. So circle goes on C. The line, the zero line of the protractor goes along CJ. And then I go 10, 20, 30, 40, 50, 60, 70, 80, 77 degrees. The measure of angle C is 77 degrees. C is the middle letter, so JCH. Now, literally, though, this is the nice thing about it. These two triangles are the same as these two triangles. So if I know the measure of angle C, then I also know the measure of angle B. Double arc. Then that means the measure of angle B, JBH, is also 77 degrees. Sorry, I realized that I wrote and you didn't see it. Thank you for using the slider part of YouTube in order to figure out, like, skip ahead, skip back. The last angle we need to find is angle H. So the measure of angle, I guess H is the middle letter, BHC. Now, this is a trick with quadrilaterals. I don't even need to use a protractor to measure it, although it kind of like guesses and checks. But here's the nice thing about it. All four angles of a quadrilateral have to add up to 360. That's not true of pentagons, triangles, hexagons. Those are different values. We'll get into that later on in this course. But right now, something for you to be aware of, if you have a quadrilateral, then all four angles must add up to 360. Take a square, for example. In a square, all four angles are 90 degrees. 90 plus 90 plus 90 plus 90, 360. So in a different type shape, like this kite quadrilateral, that means that we can actually do a little bit of subtraction. 360, take away 90, take away 77, take away the other 77. Hey Siri, what's 360 minus 90 minus 77 minus 77?
360 minus 90 minus 77 minus 77 is 116.
Thank you, Siri. So since that's the measure, you can absolutely, of course, get a protractor out and check it again, but you should be, apart from human error, able to confirm that this angle right here is 116 degrees. Thanks for watching this video. This is the rest of page 221. We're going to keep going with our textbook throughout the rest of the lessons. Thanks for watching. Subscribe, click that link, whatever, etc. Do the stuff, and I'll talk to you guys in the next video. Thanks. Bye.